damos comienzo a un nuevo workshop en esta oportunidad. Joshua Waller, Dev Advocate Dev de Phala Network, va a hacer un workshop sobre Inc. El workshop se llama How to Build an Oracle in Inc. Fat Contract. El workshop va a ser en inglés y después vamos a tenerla subtitulado con posterioridad, así todos pueden acceder a esa información. Las preguntas van a poder hacerlas en el chat y después las van a contestar al final. Muchas gracias. Joshua, if you want to start, thank you so much for be here and share your presentation with all of us. Thank you.
Thank you. Hi, everybody. I'll share my screen now. Okay, so I hope you all can see my screen, but hello, everyone. I'm Joshua Waller. I'm the dev advocate / DApp developer at Phala Network. And today I'm just going to give you an introduction to how to build an Oracle in 15 minutes. By the end of the session, you'll be able to deploy an Oracle contract and submit it for a judgment from an advanced judger contract that will then verify that your Oracle has passed the different parameters that we've set in place to ensure that you get one of these advanced badges. So yeah, and today we'll use the gist on GitHub to for your GitHub profile to create an attestation through this gist, and then the Oracle contract will then verify your gist as an attestation such that we can then give you a POAP code from our FAT badges, FAT contract that will allow you to claim a POAP at the end of this. And just to also tell you that these FAT contracts are written in Inc. And they support the Inc. WASM smart contract embedded domain specific language. And so these are going to be WASM FAT contracts. And just to give you like a little brief difference between FAT contracts and smart contracts, FAT contracts are going to be running in our secure enclave off-chain workers. So they're going to have access to the internet through HTTPS request, and you're going to have more scalable computation, since what we do is any kind of action like sending HTTPS request or say anything that's interaction with the internet will be sent through queries, and these queries are executed instantly. So there's no cost to actually send these requests. So like I said before, these are the two badges that you can win. We're going to add some more badges as well for these, since there's like a limited number, but we're requesting some more for after. So why build new Oracles? It's pretty simple. Today's Oracle market is just, it cannot meet the demand that most of these decentralized apps are requiring. And it kind of, and just to get to like the first point, it fails to serve long tails. So there's months of development to integrate to a blockchain that, like for instance, like Chainlink, they have only support for 12 EVM chains, and it takes a really long time to integrate Chainlink into your blockchain. So a lot of developers are left waiting, and they have to sort of sacrifice some of their stack to kind of utilize possibly some workarounds that aren't too clean. Also, they're not flexible enough. So currently, what we've seen in the market is like Oracles typically are just a price feed, or they provide like a verified random function capabilities, but they're not really capable of verifying or processing complex data on the internet. And another reason why we need to build these new types of Oracles, because a custom Oracle is hard. So building one from scratch can take months, but through these fat contracts, we can make it really easy for you to get Oracle up and running really fast. So the keys to build a flexible Oracle, well, you need access to the internet. So you need HTTPS requests to connect to Web 2 or Web 3 services. It needs to be programmable. So just like today's smart contracts, you would like your oracles to be able to have that programmable logic, and then easy integration. So you would want also that your oracle to be able to interact and integrate into different blockchains very fast. So there's not that long development time, and you can get up and running pretty quick. So this is where the fat contracts come into play. So like I had mentioned earlier, the fat contracts, they support internet access through HTTPS requests. They also allow you to implement arbitrary logic, which is supported through the Inc smart contract. And then also it's blockchain agnostic. So you're interoperable and you can communicate with actually different blockchains through different configurations and different contracts that you could create. So here we're going to start on the GitHub identity oracle. So as I mentioned at the beginning, we're going to create a gist. So as you can see right here on the left side with the GitHub logo, we're going to add a little phrase that says, I hereby confirm that this account belongs to substrate address, and it's going to claim our address. And then our Oracle contract, fat contract, will then verify that attestation and then redeem a POAP code for you. And this is just like the easy challenge winner right here for that process. Beginner challenge, let's see. So I'm gonna go to this link here in a second, but this is typically gonna be the DApp page right now for the easy challenge. The easy challenge, you'll go in there, you'll connect your Polkadot.js wallet, and you'll get 10 Phala tokens. From here, you'll have a little text to copy, and this is what you will paste as in your gist for the GitHub. And then once you post your gist publicly, you will then input your raw URL and verify that. And then from there, you'll get your easy challenge POAP. So let's see in the next part. So before I go into the code breakdown, if I can go back, I'll show you exactly how this works. So here for the beginner challenge, the easy challenge, you click here and say, so right now I have my Fat Warlock account connected. I'll get 10 Phala tokens, and I'll verify this. Verify this here. So I had 20 before, but now I have 30. Okay. And so first we're gonna sign a certificate. So this is gonna, once we sign a certificate, now we're able to interact directly with the FAT contract that is deployed, the Oracle contract that's deployed on the test net that we have here. And as you see here, we have the easy challenge. We have like in the slides, the text that we want to copy and post on the gist. So I'm going to copy this here. Let's see if I can. So I'll go to mine and I'll create a new one, a new gist. Say Latham Station. Say this just says owned by address. There's the code, and whenever you create here, just make sure public, create public. So now that we have that here, so whenever in here we see that you want to input your gist raw URL, just click raw here, copy this URL, paste, and then verify. So it says that this is verified successfully, and then your POAP registry can be found in the FAT badges contract page. So now we'll go to the FAT contracts badges page. We'll sign to connect to the contract, and then we'll load to see that I have claimed my FAT Easy Challenge. So there's 15 left right now, but we're going to add some more. So for whenever you test it out and try it out, then you can get your POAP code. So you can see I have mine here that I can claim. So getting back to just to show you, like this is that's the deployed application. This is how it would work. So now we can start kind of diving into like how it's implemented. So just to go into the code breakdown. So these FAT contracts are written in like Ink smart contracts. They support the Ink smart contract EDSL. These contracts will consist of a storage where the contract states are stored. So in this case, our storage would be the Easy Oracle. We have our admin, which is going to be connected to the admin account ID. We have the batch contract options, which will be an optional mapping between account IDs and the badges that have been claimed, and then our linked users as well. So just to go further, we have our mutable calls, which are the transactions which will be executed and take around like 6 to 12 seconds to execute and be stored on chain. So they will be sent from the FAT contracts and then encrypted and stored on the Phala blockchain storage. And then the queries, which is what we use for the HTTPS requests, those do not write to storage, and those trigger immediately by a direct RPC call. So these HTTPS requests are available in queries, and this is how we're able to verify and parse the data from your gist that you post and validate your attestation. Let's see if checking. Cool. All right. All right, so here are some of the functions that we have here. So the redeem, which will be where we will actually be a mutable call. So this is where we're changing the contract state. We're going to check to see if a user has already redeemed a POAP code in this first if statement here, and throw an error that would say this username already in use. And then next, if they have not claimed it, then we'll insert this this user's username into the linked users. And another one would be here. This is just a query. So this would be returning the admin account. So it would, and here with the function admin, we will return the admin that is stored in storage. So sending an HTTPS request in the FAT contracts. So whenever we do a test, this is a query call. And here you can see that we have from our chain extension, we have this function called HTTP get and the URL. So that URL that we passed in from the gist attestation, and when we hit verify, is that it'll call this, the front end will call that a test first, where we will get the information, which is here, this information from the HTTP request, and then come in here and take the response and add to the body, and then we'll extract that claim for the account, and then be able to create a quote, like a gist quote. And then within this FAT contract, we also have these attestation generators. So this is a derived key that's within the FAT contract. So in this case, it will create a key pair, and that key pair will then sign the quote and then return the result. So now we have a signed result that will have like the data that can be verified, and then also the signature of the data. And next, after we the ownership, okay, so that's kind of like what I just explained about the verification part of extracting the claim and creating this gist quote. And just to step further and show you the derived key part, where we create this generator and verifier. This is the key pair here, where we create and then we add a salt to this attestation create function. So in this to bring the result back to the blockchain, it's impossible to change the storage from a query right now, but however, we can do something like I had mentioned earlier, where we are able to take this derived key pair to sign that data, and then we can return that information and submit it to a mutable function, so that we can change the storage. And then whenever we go inside that mutable function, we're able to then use the verifier to as you can see on this bottom part, to verify that data, to ensure that the data that's being sent to us is actually signed by the contract itself, and we know that it's coming from something that has been signed by our derived key pair in the FAT contract. So this is kind of like a way to be able to use the query and then submit a transaction to change the state of the contract. So now getting into after we verify and change the state to say that you have we have verified your attestation. Now we want to reveal a POAP code and redeem that to the account that has been verified. So a good thing here is FAT contracts that like I had mentioned earlier, they're end-to-end encrypted, and that encrypted data is stored on the Phala blockchain. So this allows us to save private data, like in this case, the POAP redeem codes, without anybody having access to that data. So they can't just look at the blockchain and publicly see that, oh, here's the POAP code. I can just take it without even doing anything. This is since we have it encrypted, and then also our off-chain, our FAT contracts run in the secure enclave. The user that has deployed the contract has to then give permissions to someone to actually view these badges. And in this case, only the winners can visualize the POAP codes if they have been verified through the attestation process. So in here, you can see that we have our FAT badges and the the badge codes here with the mapping of the badge ID and the code ID, and then the badge assignment. So whenever someone is verified, then you have this mapping of the badge ID to the user account. And then whenever we have our query to get a result to see if you have a POAP code, so kind of what I showed here, where I have my code is this POAP code, but on the that advanced challenge, I actually don't. So since I haven't completed this one yet. So just to kind of show you that. And then here, we get the caller from the environment.caller call from the FAT contract. We'll take the badge assignments, see that if this ID isn't located in the badge assignments, then it's not going to be found, so that you won't be returning anything here. And then if there is one detected, then we can return that and send it back here with the OK code. So now for the advanced challenge. So the advanced challenge, you'll be actually deploying the Oracle and then submitting it to the advanced judger. So I have like a little scene here, like just like a high level overview of these 3 contracts that are involved here. So in this process, you will be deploying the Oracle contract and then submitting it to the advanced judger, who will then verify your contract, and then that will allow you to be able to mint the advanced badge. And you can see that one here. So we can go back here to the advanced challenge. Let me see, oh yeah, as what I was mentioning earlier, the advanced challenge and the verifier. So you'll verify your contract address that is deployed on the Phala testnet, and your contract, and then you'll verify here, and that's where you'll get the POAP code. So it'll be similar to the process that we just did, but instead you'll be actually deploying your Oracle. So I'll step you through building the contract and deploying the FAT contract UI. So the fat.phala.network. It's a nice UI. I'll actually pull it up now. And here you'll have a nice UI for you to connect your wallet. So you can see I have my FAT World account, and then you can upload your contracts. And I'll show you that process in a second. All right, so I had gone through some of these other steps on the verification part, and at the end we will verify in the badges contract that our advanced prize POAP redeem code is there, and then we'll redeem our NFTs on POAP. Okay, so I'm gonna start with so this is the repo for the Oracle workshop. So I'm going to post this in the chat. So for anybody that wants to take a look here, and then I'll put the other. Okay, and so these are like these will be the 3 links that will be most important for this workshop. Okay, and also in this repo, we have some pretty more extensive documentation in the README for you to read on your own, as if you want to do this after the workshop, and it'll take you through all the beginner challenge and all the steps, similar to what I had mentioned earlier in the first half of this this workshop. And kind of step you through all the things that I had mentioned with some more technical wording so that you can get a better understanding. And if you do have any other questions, you can join the Phala Discord, which I'll add in the chat as well. All right, so we're going to start on this advanced challenge. So now that we've gone through the beginner challenge section, so you kind of have like a high level idea of the basics of that contract. So now we're going to teach you how to build your own Oracle, deploy the Oracle on the Phala testnet, and use the Fat Contracts UI to play with your contract. And finally, once your submission is successful, you're going to be able to earn the advanced winner badge. So these are some prerequisites of setting up your dev environment. So installing Rust toolchain, installing Binarium, and depending on if you're using Linux or Unix or Mac OS, we have our different steps here as well of the different packages and cargo that you need to install, and some like checks to verify your installation. So I'm going to show you my terminal here. Let's see where we at. Can you reference in the prior? Sorry. All right, so I have cloned my repo here, and let's see if I can move this. And so here's the code here. You can look at the easy Oracle and here the lib. So this is our Oracle contract here. We have our submittable Oracle trait, which will be able to return your admin, verifier, and a test. We have our storage for the Easy Oracle. So we have our admin account ID, the badge contract that I had went over earlier, that attestation verifier, attestation generator. And these here, these are part of the chain extension, so you can see that. And let me just, boom. So you can see like this is within the pink utils of our Phala blockchain. So we have a attestation module here, and you can see that this is, so whenever I had mentioned earlier, whenever we sign the attestation, we'll store the data here and then have the signature here, so that whenever we return this and then send it to the mutable function, then we can verify the signature with the verifier public key here, and have the data in the signature and be able to verify that signature to ensure that this data that's being sent in is actually from the Fat contract itself. So in our verifier, we have, like I had mentioned just a second ago, was the verification process, or verify function. Takes the signing verify function, and we take a data, the public key, the signature, and the signature type, which is SR25519, and then verify and say the inner data. Yeah. So, and then the next part, like part of the key pair that's generated in the initialization of the contract, we have the private key of the key pair here as the generator, and this is what is used to sign the data. So we'll take that that gist quote described earlier. We will encode that data, sign it with the private key, and then create that attestation quote here where we have the data and the signature. So go back. Here, just kind of to go over like the full layout of the contract. You have your errors, so errors that can occur upon calling the contract. You have your type alias for the results, so you don't have to put this entire path for your return functions. So here's the we're implementing the easy Oracle. So we whenever we instantiate the contract in the constructor, we'll then this is where we derive that key. So we have that just attestation key during the initialization, and now create the generator and the verifier. We have our admin that deployed the contract, and then batch contract options are none at the time. And so then next we'll have the downstream batch contract for the config issuer. And just to sort of go through here, you have the config issuer, the redeem, attest, admin, and verifier. And then you have your structs here for the just URL, just quote. And this is like a parser to take the contents from the HTTPS request and parse the contents. Then we'll extract the claim from part of this parsing, and this is another one to decode the account ID. And here are some tests that will run, just some unit tests for you to look at, and you can modify whenever you play with the contract as well. Let's see. So I'm going to now load this on this contract on the testnet. So let's see, upload. And so this cluster ID right here is just there's only the 0 cluster right now. So, but in the future, whenever fact contracts are live, you'll have your choice of cluster to choose and be able to deploy your contract to that cluster. Let's select. Easy Oracle, and in this case, you'll you use the dot contract. As you see, I have this here, and then we'll submit it. And a nice thing here is we can check the events of us deploying the contract. And now we have the easy Oracle contract deployed. And you can kind of see all this information here. So we have our contract ID here. Transaction, and now we can interact with our contract. So this is a nice little UI, and then we have our results and a little logger here as well. So let's see. So just kind of to map everything to the front end that we had in the easy challenge. You can see like here during this redeem process, this is similar to the verify function here. And and whenever you want to say you want to configure the downstream batch contract, only admin can call it, then you would want to deploy the badges contract. So whenever that is deployed, you go here, and then you would submit the contract ID here, and then the badge ID, and then run that. See, let me then deploy. So as this is deploying, yeah, so here we have the fat badges contract. You can create new badges, you can add an issuer, remove an issuer, add code, get total badges. So in this case, we have no badges total because we haven't added any badges here. Reads the badges cosign. Yeah, so this is how you'd be able to just interact with your contract after you deploy it. So it's pretty simple in this part. I'm going to get the contract ID and go back to contracts. So now you can see both of the contracts that I've deployed. So I can go back to the Easy Oracle. And I can config issuer. So put that contract ID from the other one, badge ID. Config issue, sets the downstream badge contract. Okay. Bad. So now that transaction has taken a little bit of FUD out of my account. Oh, okay. And this is the extrinsic success here. So now I'm going to take my contract ID and go to the advanced challenge. And now I'm connected the contract, and put your contract address in for the args. All right, let's see. Following verified. So on this last part, follow the instructions on the DApp, paste your contract address and call args, then verify. So in this part, you'll be able to get your call argument here and add that here. So this like HTTPS URL, then you would verify. And after that goes through, you would be able to get your redemption POAP code. So you would then switch to the badges page that we had seen earlier. Let me find. Load. So this is the fat contract badges contract, and then you'd be able to redeem your POAP there. So we're gonna add more POAPs, but at this time I wanted to see if there's any questions from the audience that I can answer real quick. Any questions or not sure? Well, we have like 14 minutes, so I can wait if there's any questions or not. But let's see. All right. Well, I can start speaking on some other things as well. So what this was this has been updated. So I recently showed you the debugging log that we do have when activated. And then we have some unit tests, so like an end-to-end test in the contract. So if you go down, so like if you deploy your contract and you want to test it, go in here and there's the E2E, so the end-to-end test. And here you can kind of go through the process of what would need to be done to set up your local test net and deploy it. So you would be running a local test net of a Phala network, and during that you would need to deploy you need to set up your gatekeeper, which is going to be the one that will have the ability to generate contract keys for these different clusters, and then assign that to a deployed contract. So in this step, I'll just kind of like walk you through like what's going on here. What we would do is we get the worker public key, and then we set up the gatekeeper with the root account here. So we have Alice, and she's going to set up the worker that we've gotten from the worker public key. Then when we set up our gatekeeper, then we're going to deploy a cluster so that a contract can be deployed to it. So in this case, whenever we were interacting with the Fat Contracts UI, it's like this is the cluster ID here. So we have only one cluster right now on our testnet, but it's a cluster 0. And that would be, in this case, whenever you're running your end-to-end test, you would get this cluster ID here, and then you would add that to deploy your contract. So you have your artifacts, which your artifacts are going to be in here in this bin file. So in this case, these are the three contracts that you have. So you have your compiled contracts, which will have your metadata, your .contract file, your .wasm file for each of the contracts. And then from there, it'll create your Fat Contract objects. So from here, we go in, we create these objects, and now we have these contracts here. And then we go through these tests. So we're going to submit a new badge. So we have our that easy challenge badge. So they're interacting with the fat badges contract to create a new badge. We add some codes, so some redemption codes. You have the easy badge ID from up here and the advanced badge ID, and then we submit an array that will list like these different codes here. So easy 1, easy 2, advanced 1, advanced 2. So in this case, whenever we deployed our front end, we received some POAP codes from the POAP's website, from one of our POAPs that we added. And then we got a certain amount of codes, and we just added that to this add code function. After we added to the fat badges contract, we had an issuer, which you have your easy Oracle, which is able to issue different easy badges that are configured here. So it'd be these two here, easy 1, easy 2. And then your advanced judger can then, the one that verifies your Oracle contract, will then be able to disperse like advanced 1 and advanced 2. And then you configure issuer down here. So kind of like going through the steps that I was going through with the fat contracts UI of the easy Oracle, configuring an issuer, which is the fat badges contract, and then the easy badge ID. So before, I think I set it to 0, but I had not set the fat badges issuer yet. So I needed to do that before and then set that here. So that's something to look out for whenever you're running it on your own. And then whenever you deploy your advanced judger, that will then link to the fat badges address whenever you're configuring the issuer and the advanced badge ID, which is here. And then from there, you just kind of run your end-to-end test to simulate on your local testnet, actually run through the process. So from there, you just have your basic checks, easy info, the advanced info for like querying the easy badges, the advanced badges, and then you would create an attestation. And in this case, this is a link to a gist, and we're able to verify it, and then submit the attestation from Alice to redeem a POAP. And now we can see through here the fat badges query. You're able to get Alice's badge and then verify that she won. And then as we're going through, we have the advanced attestation for the advanced judger to then verify that easy Oracle contract. And this is here, let me. Oops. Sorry, I'm going to the gist here. Sorry. Go to my gist, the one I just post for the atom here, down here, and then so that would be the last steps of just submitting and having your Oracle contract for the advanced challenge verified. So here the transactions finalized. So we'll go to the fat badges contract, sign it, load, and now you can see that I have both the POAP codes that I needed for the beginner challenge and the advanced challenge. Now there's definitely just to close up, there's definitely a lot more that you can do. We have like a lot of examples, and you can reach out to me. I'm on Discord and Twitter. It's usually #warlock for anybody that needs to get in contact with me. And I can also get you the resources that you may need, or kind of show you some different implementations. Like, say, one of the FAT contracts I've worked on is like a FAT RPC, so that you can use that FAT contract to interact with RPC nodes that you want to configure and get information, and then potentially compose an unsigned extrinsic, then sign it with a derived account within the contract, and send funds to that account and execute a transaction on another chain. That's a pretty fun thing to do. And then there's other like other implementations, like I think there's a two-factor authentication FAT contract, a password manager, so many different ideas that you can do. But if you have any questions or you want any help, just let me know, and I can help you give you advice, or even show you some code that you may need to use, or what modules you need to use to be able to implement what you're thinking of. But yeah, thank you for attending, and yeah, I'll turn it back to the host.
Thank you so much, Joshua. We don't have any question in the chat. So again, thank you so much for share. And if it's possible, I don't know if you are part of the Discord from the Polkadot Hackathon Latam, and if you are available to participate, I will share with you the link for the Discord, because maybe a team can ask you things about anything related with Phala. So I will share with you the link. Thank you, and thank you so much for this workshop.
No problem. Thank you for having me. And yeah, I can definitely join the Discord and answer any questions and post them.
Yes, thank you.
All right. Thank you.
Bye.